In the project, I'm using Unity 2022.3.0 F1 and the following packages: entities and entities graphics version 1.0.16. First, we need to create a scene. I have already created mine and name it game. Then we need to create a subscene, which is responsible for converting game objects to entities. Let's name it Game ECS and save it. Since this is an editor bug that will most likely be fixed by Unity in the future, we can ignore this bug. Alright, let's move on to Rider and let's create BulletSpawnerComponentData. This is of course stacked, as I explained in the short format video. Naturally, our struct inherits from iComponentData, so let's add it. So now, to implement randomness, we must reference the Unity mathematic namespace and create a random variable named instance. Let's just fix the namespace. Great. Now we need to create an authoring class. This class inherits from monoBehavior and will help us to pass data to Baker. If we want to implement a pseudo-random system with a fixed seed, we need to create a seed variable. I assign the default value to 1 so that I don't have to change it in Unity editor. We need to add a public getter for the seed variable, so that it can be retrieved by the BulletSpawnerBaker class. Let's create BulletSpawnerBaker by inheriting from Baker and passing our class. Baker class allows us to convert data entered in the editor into data understood by the ECS architecture. Let's implement missing members. As you can see, there is a bake function with an authoring type parameter. There we can obtain an entity belonging to this class. We need to pass the none flag because we don't use the spawner's transform. Further details regarding transform usage flags will be covered in upcoming videos. Also, we want to include component data in the baking process to make it modifiable through Aspect. We need to pass entity and create a new instance of the BulletSpawnerComponentData. I use Object Initializer to pass the instance parameter. As you can see, we can access the seed through authoring. Remember to include the Unity mathematics reference to get the random struct. Now we can see if it works in the editor. Let's create an empty game object called BulletSpawner and add an authoring component. As we can see in the entity hierarchy, the component has been created and the random instance has been initialized. Everything works as expected. Let's go back to Rider and create the BulletSpawnerAspect struct. An aspect is a wrapper between component data and system. Aspects are useful for organizing component code and simplifying queries in your systems. Aspects must have read-only partial keywords. Now let's create a field for writing, RW, which we will use to communicate with component data. In the aspect, we will write a function responsible for returning the random spawn position. Random position y equals to BulletSpawnerComponentData.value RW. We should use it to avoid impure struct copy. .instance, .nextFloat, and we can pass parameters like -10 to 10 and return new float 3, 0, random position y, 0. Now that we have our mediator, let's move on to implementing the system. We need to create a new file, BulletSpawnerSystem. Systems are responsible for executing logic. The system also has the need to add the partial keyword. It inherits from ISystem. There are three basic methods in the system: onCreate, onUpdate, and onDestroy. Let's look at the interface for details. OnCreate is equivalent to awake, onUpdate to update, and onDestroy is destroy in monobehavior. Let's go back to BulletSpawnerSystem. We will be using BulletSpawnerComponentData, so let's add a line of code to the onCreate method, state.requireForUpdate BulletSpawnerComponentData. The system will not start its action, it update, until all required for update are met. Let's introduce a helper variable that will be used to check whether the system has already been started. Now we can retrieve the BulletSpawner singleton entity using the system API's getSingletonEntity method. By having an entity, we can retrieve the BulletSpawnerAspect through the system API, which will be used to call the previously written getRandomSpawnPosition. Next, we'll create a for that runs 5 iterations to verify that the code actually works and that we get random values in the console. And of course, let's fix variable name from I to index. Okay, let's go back to Unity and set the seed on BulletSpawner. Changing the seed immediately changes the state of the random instance via Baker. Let's run the game, and we got 5 random values. However, these values are the same at every game start. If you change the seed, the values are different, but it is still a result that is repeated every time you start the game. So it's no so random for us. So let's go back to IDE and get rid of the previous code in the BulletSpawnerAuthoring. We can create the initial index of a random instance using system.random.next from 0 to int32.maxValue. Of course, next result is cast to uint. Now we can use the random.createFromIndex function in the bake method and pass the initial index. Okay, let's move on to aspect. Now, each time we use the getRandomPositionSpawn method, we randomize the index of the instance by calling random.createFromIndex function. This approach ensures that the numbers will be pseudo-random. Let's test the code in Unity. As we can see, each time we get a different instance, and the numbers vary between runs of the game. Well done! We implemented randomization in ECS. Thanks for your time. I encourage you to subscribe to the channel and support us on the Patreon. And I hope to see you in the next video.